In this review video, we are going to be reviewing solving equations, specifically linear equations. So we are going to start with what it means for something to be a linear equation. So first off, we are going to start with the definition. A linear equation has a variable, typically x, and it is raised to the first power, and that variable x is not inside or under any operation. So under anything. So the easiest way to think about this is if you were graphing this, the word linear has line in it, so the graph will be a straight line. But the best way I can explain this is with examples. So first here, we're going to give examples of linear, and then over here, we will give examples of nonlinear. So first, linear. The x will be raised to the first power, or the variable. So x plus 3 equals 4. You can see that this is to the first power. Another example, negative 4n plus 3 equals 3n plus 6. Once again, this is to the first power. The variable is to the first power. Now, not linear. X squared plus 5 equals 9. That is not linear because the x is raised to the second power. Absolute value of x plus 3 equals 4. That is not linear because the x is inside of absolute value bars. Next example, square root of x plus 4 equals 8. Look at the location of x. Yes, x is to the first power, but x is under the radical. Next example, 2 over x plus 3 equals negative 5. Look at the location of x. Again, it is to the first power, but it is in the denominator. So that makes it a rational function. Last example, 2 to the x power equals 3. Yes, again, x is to the first power, but x is the exponent. So x must be in the numerator. It must be by itself, raised to the first power. The nonlinear examples, you can tell in every example it does not follow the definition. Now, some helpful hints as you are working with linear equations. The first and foremost rule is you're always going to ask yourself something. Sorry about that. Let's do that again. You're always going to ask yourself this question. Let me see if I can get that again. Always ask yourself this question. What steps do I take? What steps do I take to get the variable by itself? Now, a lot of times in math, we call this the golden rule. If you do it to one side, you must do it to the other side. So, in math though, we know that rule is simply balance with inverse operations. Balance with inverse operations. Now, I'm going to review with you the properties of equality, which makes all of this happen. So you always ask yourself, what steps do I take to get the variable by itself? You do unto one side as you have unto the other. We are going to balance with inverse operations and properties of equality. The next thing I want you to remember is I'll prefer that you work with fractions. Work with fractions. My computer is not cooperating. So work with fractions. Why, you ask? Fractions are exact. They are not rounded. If you check with fractions, improper fractions, everything's going to work out nicer. The next thing, I expect you to show your work. And always check your answers. Always plug back in and check those answers. Now, two definitions here. The first one I actually messed up on. I gave you the word that goes in the box right here. So it says an equation is a mathematical statement that shows two expressions are equal. So in the previous video we talked about an expression. It did not have an equal sign. So an equation would be expression A equal to expression B. You are saying the two expressions are equal. Next, a solution. A solution is any value that makes the equation true when substituted for the variable. Now, next, this is very important. We are now going to talk about the properties of equalities. So, it says the properties, there it goes again, the properties of equality state that you can perform the same operation on both sides of the equation without affecting the solution. Now, the properties of equality, it's basically common sense, but I need you to understand they are dealing with equality. The word equal is in all of that. So as you look at this statement, you have an equal sign in all of them. So the properties of equality is telling you if you do it to one side, you can do it to the other side. So this is the addition property of equality. If you have a side A equal to a side B, then you can legally add C to A and legally add the same thing to B without affecting the solution. So that right there is called the addition property of equality. The subtraction property of equality. You can take A, subtract C on this side, take B, also subtract C on this side. That does not affect the solution. The multiplication property of equality. You can take A, multiply this side by C, just like you can multiply this side by C. The division property of equality. A divided by C, B divided by C. So you can take each side and do the division property of equality. Now the last one here is called the symmetric property of equality. I need you to see the root word symmetric here. This is symmetry. It is the same on both sides. Now I do not want you to get this confused with commutative property of addition or multiplication. Notice it's an equal sign here. This is the symmetric property. If A equals B, then B equals A. So notice how they switch around an equal sign. So it's not commutative property of addition or multiplication. It's the symmetric property. It's the same on both sides. Now you may ask, why would I ever need to know that? Well, you would need to know that in many situations. This is the easy situation. If you work an equation out and you get 8 equals x, well, the reason why you can turn that around is the symmetric property of equality. So you can say x equals 8. Those are both the same thing. Now, why do you need to know the properties of equality? Well, as you get into higher level math, you're going to figure out that you have to prove, you have to justify. In math, everything is definitions. So when it says to justify something, they're asking you to make a proof. Now, listed below is an example of a 2-column proof, except we're going to do the proof in algebra. So on the left side, you have the algebra problem, And on the right side, you have the property, the justification. So I'm going to model the first one here for you. You ride along with me. So we have a problem, x minus 3 equals negative 5. The property for this is that is what is given. Now, something has happened to the previous step. They have added 3 and they have added 3. The reason why they've done that is they've done the inverse operation of subtract 3. Now, the justification of adding 3 to each side is called the addition property of equality. And we're going to abbreviate that POE. Now, the next step they've done is they have actually combined to get the 0 and combined to get the negative 2. So the most logical thing to say for the property here is combine like terms, because we actually combined integers together. Now, if you're dividing, sometimes that step is just called simplify. And now we finally arrived at the answer, x equals negative 2, and we simply say solution. Now, I would like for you to pause the video and work number 2 by yourself. Okay, now as you can see, I have given for the first step. Then I have the division property of equality, because you can see here, this side was divided by 12, this side was divided by 12. Now this time, instead of saying combine like terms, I actually simplified this to 1 and simplified 30 divided by 12 to 5 halves. So I called that simplify. And then you have the solution. Now we're going to go through some cases that you will encounter when solving equations. The first case that I want to review is the multiplicative inverse. Now, if you recall, the multiplicative inverse is when you have a fraction 2/3 times its reciprocal 3 halves, and when you multiply them together you get 6 over 6, which is 1. Another way to view this, the 3's cancel each other out, the 2's cancel each other out, you get 1. So when you are solving an equation that looks like this, 2/3 x equals negative 12, I do not want to ever see divide by 2/3, divide by 2/3. That is not proper math, and I do not want you to ever do that. What I want you to do is I want you to use the multiplicative inverse. I want you to use the multiplication property of equality, multiply this side by 3 halves, multiply this side by 3 halves. This cancels out to 1x. Your goal is to get x by itself. And this side you can either say negative 36 over 2 if you multiply straight across, or you can say 2 goes into negative 12, negative 6 times. Negative 6 times 3 is negative 18. You get the same answer either way. So, I always want you to use the multiplicative inverse, multiply by the reciprocal when you're dealing with that type of equation. Next is clearing fractions. If you have an equation 4/7 plus 2/3 x equals negative 13 over 21, and let's say you do not have a calculator. So I do not want you to start out by subtracting 4/7 on both sides. That's just way too much work and way too much time. But instead, what I want you to know that you can do is that you can look at the denominators and you can get a lowest common denominator of 21 in our case. And you can take both sides, and remember this was an equal sign right there. You can take both sides and multiply this side by 21, so it would be this side by 21, and you would multiply this side by 21. So we are doing the multiplication property of equality. We're multiplying both sides. So basically what that means is that every piece gets times 21. So 2/3 x times 21 equals negative 13 over 21 times 21. So you can see everything, we're keeping everything balanced, and we're going to multiply everything by 21. Now, what's special about 21 is everything's going to clean up nicely. 7 goes into 21 3 times. 4 times 3 is 12. 3 goes into 21 7 times. 2x times 7 is 14x. And in this last piece, after the equal sign, the 21's cancel out. We're left with negative 13. Now we subtract the 12 from this side. We end up with 14x equals negative 25. Divide both sides by 14. Remember, I said always work with fractions. Just leave it. Do not type that in the calculator. Negative 25th or negative 25 over 14, that is an exact answer. Next is multi-step equations. A multi-step equation is just like its name sounds. Our example will be 2 times x minus 6 minus 7x equals 14. So the first thing we would do is we would apply the distributive property. We would distribute the 2 to the x and the 6. We would get 2x minus 12 minus 7x equals 14. We would now combine like terms. The x's are like terms, and they are on the same side. So that is negative 5x minus 12 equals 14. We would add 12 to the other side. Negative 5x equals 26. Divide each side by negative 5, the division property of equality. X equals negative 26 over 5. Leave your answer as a fraction. Next is variables on both sides. We have 2x minus 5x equals 3 times 1 minus 2x. So on this side, you would clean up the left side first. So I would end up with a negative 3x. You would clean up the right side next. You would have 3 minus 6x. Then you must collect the variables on one side. Now it doesn't matter, but typically the rule is you bring to the biggest one. So negative 3 is the biggest one. So I would add 6x over here. So I end up with 3x equals 3, because that would cancel out. Divide each side by 3, x equals 1. Now, of course, in all of these examples, you can go back and check your answers to make sure your solution works out. Now, so far, what makes those 4 equations special? They've all had one solution. So one solution. Only one real number will work. Now what happens is when you have variables on both sides, you get 2 cases that pop up. And those 2 cases, one is no solution, and the other one is all real numbers. But I have found over the years, you mistakenly use infinitely many solutions. It is not the same thing in this case. So first let's look at something that has no solution. So we have 9x plus 5 equals 4 times x plus 2 plus 5x. Now we have variables on both sides and it's multi-step. So the left side will stay the same, 9x plus 5 equals 8x plus 8, not 8x, excuse me, 4x plus 8 if I apply the distributive property, plus 5x. Clean up both sides. This side will remain 9x plus 5. The other side will clean up 9x plus 8. Now, you can already see these two sides cannot equal one another. Whatever x is, whatever we put in here and here, the 9x is the same, but the 5 and the 8 is not. Now, if you do not realize this, you would say negative 9x, negative 9x. Those both would cancel out and you would get 5 equals 8, which is false. That cannot happen. So that means there is not a number anywhere on the number line, fraction, decimal, whole number. There is simply nothing that will work. So this is truly a no solution. Now, the next case is all real numbers. Remember, sometimes you use this and it's in the wrong context. So first, let me explain to you the problem. Here is our problem. 3x minus 12 equals 3 times x minus 4. Now you notice, if you apply the distributive property on the right side, you get 3x minus 12. Now those are identical sides. The 3x minus 12 is the same thing as 3x minus 12. If you didn't realize that, and you actually subtract the 3x on each side, you will get negative 12 equals negative 12, which is true. So this one does have answers, okay? And yes, it has a lot of answers. But you do not use infinitely many solutions. Let me explain why. So you have a number line, and on a number line, there's bunches of numbers. There's numbers in between here. There's decimals in there. They're everywhere. So when I say all real numbers, I am talking about the number line, all of it. Everything, fractions, decimals, will work into this equation. Now, a lot of times you will abbreviate infinitely many solutions, IMS. Okay? Now, let me explain to you infinitely many solutions. If I were to take this piece of the number line, 1 to 2, and I ask you to write down every number, every single number in this, you could not do it because there's an infinite amount of solutions, but it's only between 1 and 2. So infinitely many solutions exist in this little piece, this little interval here. And yes, infinitely many solutions happen up here, but it's restricted. So you do not use infinitely many solutions here. The correct term is everything, all real numbers. So I do not want you to use infinitely many solutions when you're solving linear equations. Last but not least, we must talk about word problems. This one says, find 3 consecutive odd integers such that the sum of 7 times the smallest and twice the largest is negative 91. Well, the first thing you have to identify is your unknown. Well, we are really dealing with 3 unknowns, but we also have to know math. So we need the first odd, we need the second odd, and we need to know the third odd number. So we have the first odd, the second odd, and the third odd. Now the problem says to find those consecutive integers such that the sum of 7 times the smallest and twice the largest is, trigger word for equals, negative 91. So the first thing is we have to have a starting point. It is an unknown. So our first odd is our unknown. Now a little bit of math about numbers. 1, 2, 3, 4, 5, and so on, those are consecutive numbers. But this says odd. So 1 is odd, 3 is odd, 5 is odd. How many spaces apart? They are 2 spaces apart. So whatever this number is, it's 2 spaces ahead of to get to the second odd. And the third odd, from 1 up here to 5, that's 4 spaces. So that is x plus 4. So to set up our problem, we have 7 times the smallest. This is the smallest. So this right here is going to be x. And twice the largest, that's the largest. So x plus 4 equals negative 91. So now I would like for you to pause the video, work that problem out, and give me the 3 consecutive odd numbers. Okay, I have continued working the problem here. I made it down to the answer as x is negative 11. That is an odd number. So our first odd number is negative 11. If I add 2 to negative 11, I get negative 9. If I add 4 to negative 11, I get negative 7. Now, testing that out, 7 times the smallest and twice the largest is negative 91. Negative 77 plus negative 14 does in fact equal negative 91. Therefore, it works. Now, if I were to ask you to do this on the test, I would look for the setup of the equation. That concludes this video.